Hi everyone from ClimateWins. I'm Mathieu Dacol, your data analyst. And as you recall, you asked me to see if machine learning can be used to predict if weather conditions will be pleasant on a certain day or not. So let's dive into this comparison study of supervised classification algorithms. Just bear with me, there are only going to be three models. But just before talking about machine learning, let's talk about our data. So we have two data sets. The first one, owned by the European Climate Assessment and Dataset Project, basically has all the weather metrics from 18 weather stations in Europe. So by metrics, I mean temperatures, wind speed, humidity, precipitation, and so on and so forth. And spanning from January 1960 to October 2022. And the other second data set is on the same time period, but for only 15 weather stations, and it holds all the tags indicating whether the weather is labeled as pleasant or not pleasant. In our potential bias or some limitations from those both data sets, we may notice that the evolutions of used instrumentations or metrics over time can introduce inconsistencies, meaning that we might not have the same tools at hand in 1960 and the same right now in 2022. Also, any general assumption based on this study must be taken lightly since the sample of weather stations isn't really representative of the whole Europe. So we have only one city per country. So in Spain we have Madrid, in France we have Tours, in Rome, in Italy we have Rome, and etc. Also, the labeling, all the tags for pleasant or not pleasant are highly subjective and it depends on cultures and different person. And also the algorithms used are only for classification purpose, so they won't be of much help if we were to predict or forecast how the weather will be evolving in the future years. This next slide shows how the model will be applied in this study. On the left side, you can see that I could write this slide because I made the mistake at first. So I applied first all the models on the whole data sets from the whole stations to all the tags, meaning that my models were trying to predict if weather in Madrid was pleasant or not by looking at the weather in Stockholm, in Tours, in Rome, and etc. So it was completely overfitted, as you can see underneath in the decision tree example, with highly complicated and overfitted models. So what I did was to discriminate comparison. So I invite you to look at the right of the screen, where we only checked the labels for one city to the weather metrics of the same city at the same time. So the Madrid tags are only based on weather metrics, and etc. for each weather station. So now that this is clear, let's go in the first model we used, the key nearest neighbor. The key nearest neighbor is an algorithm that classifies data points by comparing them to the closest neighbors and assigning the most common class among those neighbors. So it's a model prone to bias because it's only the majority vote. This model was quite successful with 94.3% of global accuracy. With Sunblick has a particularity because it only had unpleasant days. From Austria, it's up in the mountains. And you can see on the right the confusion matrix showing how on the testing data, how well performing it was. And it shows that the tags for well-performing weather stations, like in Valencia, are not very well balanced for the ratio of tags, meaning we had more pleasant days than unpleasant days, so the models couldn't learn very well, and so having some more false negatives. The second model was the decision tree. This decision tree splits data into branches based on feature values, creating a tree structure to make predictions. You can see we have a 100% highly accurate score, which is really awesome. And for example, I just selected two cities from Budapest and Basel, and all cities had the same inputs, the same decision trees based on first the temperature being lower or higher than 17 or 95 degrees Celsius. Then it went to the precipitation, so how much rain we had. Was it lower or equal to 5 millimeters? And finally, the sunshine. Was it lower or equal to 0.95? I don't have the units of the sunshine, but 0.95 doesn't really highly evocate something, but we can guess that it would be much of a sunny day or not. So this model was performing really well, and so the first the main metrics used was really temperature, the main discriminating part. And then the Feynman model was artificial neural network, the ANN. It tries to mimic the human brain by using interconnected nodes, so neurons, to process data and make predictions. This model is much more complicated on the maths behind, and with some hidden layers too, meaning that even data scientists don't know really what happens in those models. So this being said, this model was best performing when we had less hidden layers and few numbers of nodes. So the simplest the model was, the best it performed. So the best performing I could do at this time was 99.77% of accuracy, which is really good. And we can see that on the confusion matrix on the right, the model best performs on the stations where there are balanced pleasant and unpleasant days, like Belgrade and Madrid. So now that we overseen the three models, we might have some ethical issue in our study, meaning that if we were to guess wrong on these labels for future weather conditions, we might cause some impacts on society, like I could guess, imagine some real estate speculation or some increasing migrations, or maybe some others concerns. So we'll have to be careful. Now we might ask ourselves some hypotheses. Just we would like to investigate a bit further. Is by will machine learning models be capable to predict climate changes over the next years? So it won't be these models, specific models, but can machine learning actually predict next climate changes? And are decision trees also capable to adapt to more stations over the world? Because now we saw that it worked perfectly well for 15 stations, but since we have plenty many in Europe, will it be as performant? And if climate changes, will people tend to move before adapting to their new weather conditions of living? So we might not have the good data sets for right now to answer these questions, but people might just not move and adapt to their new weather conditions. So is it more likely to have migrations or not? As for a few recommendations from this study, the classifying pleasant days based on weather parameters, decision tree are the most accurate algorithms. However, if more data were to be crossed, the ANN models should not be disregarded. So I wouldn't keep the KNN, I would just really focus on the decision trees. And if we had more complex data, really use also the ANN models and try maybe enhancing these ANN models. So this is the third recommendation, with more iterations, new parameters, and or helping it by adding an optimization like some gradient descent, just to make it perform a little better. Also, applying these trained models to larger data sets, larger time period, and more weather stations, it could be really beneficial in order to test their consistency over time. And another study could involve a combinations of all these algorithms with time series analysis and forecasting in order to foresee the next most pleasant places to live in Europe. So this would be a really great forecast in and delving into the future. So thank you for listening. I hope it was really clear. And if you have any question, just please don't hesitate just to contact me. Just drop me an email, send me a LinkedIn, or flash my QR code with my portfolio where you can have a chat with me. And if you're really interested in all the technical aspects behind all of these results, I invite you to check my GitHub repository with all of the scripts available. So thank you for listening, and I hope you have a good day.